Okay, so I'm back, and we're first going to look at the sedimentary rocks that are classified as being detrital. So if we go back up to here, that's going to be all of those rocks that are in that brown area. So the first one is going to be a conglomerate, and the first thing you notice about the conglomerate is it's made of fairly large chunks of rock that have been cemented together. Then the next thing that you should notice is that those chunks of rock are rounded. So what does that tell you? Okay, that means that particular rock probably formed in a river, and it either had enough time to be rounded, or it spent a long time in the river bouncing around, and that was what caused the rocks to be rounded. Now compare that to breccia. So breccia is made of exactly the same materials as what the conglomerate is, but you'll notice that the pieces of the rock are more sharp. They're more angular. Okay, and so what that means is if you find a breccia, it probably has not been transported very far from where it formed. On the other hand, the conglomerate probably has been transported a fair distance from its source rock. Okay, then you've got the greywacke. So the greywacke is going to be composed of, you can see there's some pebbles in there, there's some sand in there, and then there's some clay in there, and some feldspar. So it's just a jumble of all sorts of different kinds of rocks put together. Okay, so what could cause one of these types of rocks to form? So maybe you've got a avalanche or something where you've got all sorts of different kinds of rocks tumbling down the slope, and then they all land together and get cemented together, and then that could be a greywacke. On the other hand, you could have an underwater valley where you've got debris that comes off the continent and it builds up on this underwater slope, and then all of a sudden it starts to have another avalanche down to the bottom of the ocean floor where it's all messed up, and then it could be cemented together and make that kind of a rock. Okay, what about the sandstone? So the sandstone's going to be made of quartz. It's sand-sized grains, and you'll notice that the sandstone is very clean. Doesn't have a lot of other minerals in it. Now there's two places where you can find a sandstone. So they could be found in a desert. So sand dunes could be petrified and turned into sandstone, or you could find sandstone on a beach. In both cases, either the wind or the water has uniformly mixed up the sand grains so that they're all a uniform size. Now, how could you tell the difference, though, between a sandstone that formed on a beach and a sandstone that formed from sand dunes? Well, what you do is you look at the sand grains under a microscope. And so if the sand grains are polished, then that means it was on a beach. If, on the other hand, they have pits in them where the sand grains have collided in the air, then that's an indicator that it's going to be from a sand in a desert. Okay, then you got arkose. So arkose is like a sandstone. It's got a lot of sand in it, but it also is going to have some feldspar in there. Now, what would that tell you? Well, that's telling you that this sand has not been thoroughly mixed together, and that the feldspars have not had a chance to decompose into clays. And then after that happens, normally the clays wash away, and then you're going to be left with just the pure sand. Okay, the siltstone is going to be made of silt-like particles, And so you tend to find siltstone off the coast of a continent. So in the ocean, further out to sea, where the silt can be carried out there, and then it settles onto the bottom to make siltstone. Shale, on the other hand, is going to be made from mud and clay. So these are going to be particles that go out even further out into the ocean before they finally settle down to the bottom. So you're going to have sand on the coastline and out to sea, but fairly close to the shoreline. Further out to sea is where you're going to have your siltstone, and then further out still is where you're going to have your shale. All right, so now let's talk about chemical precipitates in our next segment.